Hello, everybody. Welcome back. Uh, I don't know if you guys noticed this last time or not. When I was last streaming, I may have forgotten to unmute my desktop audio. I just as I was starting up stream today, I realized that my desktop audio was still muted. So, whoops. Sorry about that. me get rid of those. More bots, like usual. Get this gloves on. Also, I had just during the starting soon situation, I actually just applied for the Twitter subscription thing. That way I'll now have a little blue check mark next to my name. Isn't that exciting? Sorry, I bumped the mic. Sorry, I'm finishing up here, getting my gloves on real quick. And then we'll start it right on up. There we go. Oh, let me get my light. There we go, much better. All right. Close out of this. Make sure everything's running on this stuff. Real quick check. Make sure everything's running properly. Where were we? That's fine, that's fine. I need to fix the title. Click save all. Let's see it now. Alright, refresh my YouTube just to make sure that changed there too. Yes, it did. Alright, hell yeah. We back into it, baby. And hello. Welcome back once again. Last time we were doing this, we're working on this. And I know probably couldn't hear the last bit of this whole thing, but the whole enums and dictionary thing, I got kind of I'm happy I'm learning more stuff, because now I'm a little more excited. Like, I'm feeling invigorated today, as the title suggests. So, you know, I'm more excited to work on this stuff. So, let's see what we got here.
Buffs and so on. Enums. Enums are a convenient way to define tag.
Because this is nice. Having this as like a thing. Very nice.
Go into our boss, and we access the health. And this prints 500, which is correct. So this way we can start to think of ways we can structure data about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units, and we want a way to mark each one as either hostile, neutral, or ally.
This is what I remember.
In this case, we could create an enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy.
Yeah,
and now we can use these states in our game. For example, we can create a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to stay organized. So I'm going to call this alignment. And now whenever we are accessing a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment dot ally by default. And then inside of ready, we can check if unit alignment is equal to alignment dot, let's check for enemy. And if it is, we will print you are not welcome here. And if it's not, so it's not an enemy, we'll just write welcome. And now if we run, we can see that our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the inspector. So I'm gonna set mine to enemy here.
Hell yeah.
And now when we play, it prints you are not welcome here. Really cool. Now what is actually happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value. Which means that if we try to print one of these states, say we print alignment dot enemy, the console simply shows the value of that constant, which is 2, because it's the third state. This is rarely something you need to take into account, but it's nice to know what our code is actually doing. And we can even override the default value if we want. So we could set ally equal to 1, neutral equal to 0, and enemy equal to -1. And now our console displays -1 because that's now the value of our enemy constant. Now something that pairs really nicely with enums are match statements, because they allow us to quickly add functionality for each state. Match. Match is the Godot equivalent of the switch statement from other languages. It allows us to execute different code depending on the value of a variable. In this case here, we can use a match statement to add some code for the different values of our enum. So I'll write match, then the variable we are matching based on, which is my alignment, colon, and now we add code for each value. So in case my alignment is alignment.ally, I'll print hello, friend. If it is neutral, I'll print I come in peace. If it is enemy, taste my wrath. And a cool thing here is that we can actually add a default response as well. To do that, we do _:. And so if it isn't any of the cases above, we'll print who art thou? And if we set my alignment to say enemy, taste my wrath. Modifying nodes 2.0. So far when
let me actually look back at this. He was just still doing enum stuff, right? Yeah. Okay. I was like weirdly unsure about that for that. But the default thing is pretty good.
Who art thou? And if we set my nodes 2.0. So far, when we need to access a node, we've done so by simply dragging it into our script, which creates a $sign followed by the path to the node. I've created a few empty nodes here to demonstrate. A player node with a graphics and weapon node, and an enemy node. So if I drag in the weapon node, it creates a path that goes into the player and finds the weapon. And we can actually store this reference in a variable. To do this, we simply drag it to the top and hold down Ctrl while releasing. This automatically creates a variable with the name of the node and the correct path. And as you can see, it uses the onReady keyword. This is because Godot has a very strict order in which nodes are created. And if we open the game and try to find the weapon node before it exists, we will get an error. OnReady simply makes sure that Godot waits until all child nodes have been created so we don't get any issues. And just a quick note, the $sign here is actually just shorthand for using the getNode function. So this is actually identical. Also, you might have noticed that the path is relative. Our script is on the main node, so it starts right after that node. We can print the absolute path through script. We'll print weapon.getPath. This prints the absolute path starting from the root of our game all the way to weapon. Now paths are great for many things, but sometimes they can be a bit inflexible. They break if we rename any of the nodes in the path, and it's best to only use paths when the node we want to access is a child of the node we are working on. We'll talk more about parent-child relationships later. Luckily, we can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node 2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable
Let me
here,
go back a bit.
Now we can only assign We can also use the export keyword to reference other nodes. So if we write export and create a variable called myNode, we can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using
How do you
back
do this again?
and create a
just
variable
typed it in
called
manually.
myNode. We can set the type to node. And then in the inspector, we can assign whatever node we want, or simply click and drag. I'll drag in the player. We can also check if the node is a certain type by using the is keyword. So in ready, we'll check if my node is of type node 2D, in which case we'll print is 2D. And it is. We can even be specific about what type of node we want to be able to reference. If, for example, we only want to reference sprite nodes, we just change the type to sprite. So sprite 2D. I'll reset the variable here, and now we can only assign sprites, which in this case are the graphics and weapon nodes. Now, if we play, it still prints that this node is a 2D node, even though sprite 2D and node 2D are two different nodes. This is because sprite 2D inherits from node 2D, but we'll get into that in the inheritance chapter.
Got it.
Signals. Signals are messages
No,
that
my
nodes can
worst,
send to
my
each other.
biggest
We
enemy.
use them to notify that a certain event occurred. It's probably easiest to look at an example. Godot has many built-in signals. Take this UI button. If we select it and go to Node, we can see a list of all the signals on this node. I'm going to connect the pressed signal to our main script. So double-click it, I'm going to select main and hit connect. As you can see, this creates a function called onButtonPressed, and over here there's a green arrow pointing to it. This means that a signal is currently connected to this function. If I click on it, we can see the source, which is our button. Let's just add a quick print line here. And now if we play and press the button, it prints money. Get it? Now this is because whenever we press the button, it emits the pressed signal and everything connected to it gets called. In this case, our onButtonPressed function, which indeed prints money. We can connect as many functions as we want to a signal. They will all be called when it gets emitted. This is really cool because it allows us to link together nodes in a way where they don't have to be aware of each other. The button has no idea which functions are connected to the signal. It just tells it to emit. This makes signals great for separating different parts of our game, or decoupling. Say we're playing a character that can level up by getting enough XP. Whenever we level up, there are probably many game systems that need to update. The UI, our player stats, perhaps we have spells or achievements that unlock, and updating all of these from the player can quickly become a mess. Instead, we create a leveled up signal that all these systems can connect to. Then all we need to do is have the player emit the signal when we level up. Let's try it out. Instead of a button here, I'll create a timer. So I'll add a timer node and set it to auto start. This will count down from 1, and when it reaches 0, it emits a signal called timeout. Let's connect that to our script and make it increase our XP. So we'll create an XP variable, default it to 0. Then in our function, we increase our XP, and let's also print it. If our XP then reaches, say, 20, we'll set it back to 0, we leveled up, and we can start over for the new level. And if we then play, it's going to increment our XP every second, and when we reach 20, it's going to go back to 0. Now let's create a signal that other nodes can connect to. So at the top we'll write signal, leveled up, and if we save this and select our main node, we can actually see that signal. We can connect it to other nodes, but just for this example, we'll connect it back to our main node. This creates an onLeveledUp function, which is called when the signal is emitted. Let's print a message that says ding. Now we simply have to emit the signal. Let's do that when we reach 20 XP. Here we'll write leveledUp.emit. Now when we reach 20 XP, it emits the signal and we print ding. Awesome. We can also connect signals through code. I'll disconnect the signal in the editor, and instead in a ready function, I'll write leveledUp.connect and the name of the function we are connecting to, on leveledUp. Careful here, this will probably autocomplete with parentheses. We don't need those, we just want the name of the function. And disconnect.
Okay, hold on. What do you think? So here. And so connects. connects the signal leveled up to the auto leveled up signal.
Is just as easy. Disconnect. We can also pass parameters through signals. This could be used to pass the level we reached or other useful information. I'll just add a quick message that we can print. So on a signal, we'll add a parameter. We'll make sure that our function supports this as well. And instead of printing ding, we'll print whatever message was input. And then when we emit the signal, we can put in a message. Let's put in grats. And voila, it displays grats. And that is signals. Get, set, go! Or just get set. Getters and setters allow us to add code for when a variable
I think
is
you did
changed.
a better job at explaining signal than I've ever, like, all that time I did researching it. Like,
And
holy shit.
voila, it displays grats. And that is signals. Get, set, go!
I got to go
Or
back and
just
review it
get
again
set.
just to make sure I get it right, but I think you did a really good job at it, honestly.
Getters and setters allow us to add code for when a variable is changed. This means that we can do things like clamp a value within a certain range, or emit a signal letting other parts of our code know that the variable changed. The example that is always used for this is health. So we'll add a health variable, default it to 100, and then we'll use a colon to go and define a setter. In the parentheses, we name the value that was passed in. So this is the value that we are trying to change our variable to. And now we can decide what to do. We could, for example, set our health equal to not the value directly, but clamp it first between 0 and 100. So this makes sure that our health does never exceed 100 or go below 0. We could also emit a signal here, so we can create a signal. Health changed, and we can actually input the new health as a parameter. And then in our setter, we can go health changed dot emit and put in the new health. Of course, we need to make sure to connect this signal. We can do that through the editor, and let's just print the value. So we'll print the new health. Then in ready, let's try this out by assigning a value to health. Let's try assigning -150. And now if we play, we can see that it prints 0. This is because we put in -150, it clamps this to 0, and then it emits the signal. The signal then calls the onHealthChanged function, and we print the new health, which is 0. So that's a good example of adding a setter. Getters are more commonly used to convert values. So let's add two variables. We'll have a chance that is equal to 0.2, and then we can have another one, which is our chance in percent. We'll make this of type int, and we will add a getter. Here, whenever we try to get the chance percentage, we'll simply return the chance variable times 100. And now if we try to print this variable, print chance percentage, or change our chance to, let's say, 0.6 and print it again, we can see that our chance percentage is completely based on whatever our chance is currently equal to. And so it starts at 20% and then goes to 60%. And for good measure's sake, we'll add a setter also. So if we set to a new value, we will modify our chance and set it equal to the new value divided by 100. And since our chance is a float, we'll make sure to cast that value. So now instead of changing the chance, we can directly change the chance percentage to say 40. There we go. Classes. This is a good one. GDScript is an object-oriented programming language. This means that we generally try to structure our code inside of contained objects that interact with each other. We primarily do this using classes. For now, try to think of a class as a blueprint. Say, for example, we are making an RPG and we need to populate it with a bunch of characters that the player can interact with. So we create a character class that has some variables and logic that all characters in the game should have. So for variables, we could add things like name, health, and a line of dialogue for when you interact with them. For logic, we could add functions like talk and die. Then we take this class and create instances. Instances are specific versions of the class. So we could create an instance named Potion Seller that has a health of 50 and a line that says, "You can handle my strongest potions." And a bunch more instances, all of which have the same variables with different values, and all of which can talk, "I used to be an adventurer like you," and die. So that's the idea of classes.
Nice.
In Godot, you've actually already encountered a bunch of classes. That's because all the built-in nodes in Godot are classes, which actually makes a lot of sense if you think about it. All the nodes are self-contained objects with a bunch of variables and logic that we can create instances of. If we add a sprite node, we're instancing the sprite class. So when we create a script, we are actually also creating a class. I have to put a disclaimer here that we are technically not creating a class, but for all intents and purposes, it works just like one, so let's forget all about that for now. So let's abandon our main script here for now and instead create a new node. So let's search for node and let's name this node character and add a script to it. Now to make it more clear that our script is a class that defines a character, let's set the class name to character. So right at the top here, we'll go class name character with a capital C. And we can now add some variables. We'll mark these with export so that we can set them in the inspector for each character instance. So export var. Let's add a profession of type string and give each character a health as well of type integer. And so now we can see that our character here has these two properties in the inspector, and we can go ahead and fill out the profession. This is going to be the potion seller, who is going to have a health of, let's say, 40. And now we can create more instances by duplicating this node. So let's duplicate it a few times. The second character here will name X Adventurer with a health of 30. And the last character will be our knight, and we'll give him a health of, say, 150. So now we have these three instances with different properties, and we can also give them a function. So let's add a die function. So write func die, and this function is going to set our health to 0, as well as print our profession and the fact that we died. And that's it for our character class, but currently nothing is triggering this function. So let's go into our main script now. And here we can get a reference to one of our characters and call the die function. We could simply drag and drop one of these nodes to get a reference, but because we have named our class, we can actually use an export variable for this instead. This way we can set the connection in the editor and we don't have to worry about the path changing. So we'll write export var, and here we'll have a character to kill of type character. And now if we save that, we can see that our main node now has a slot here for the character to kill. And we can either drag in one of these characters or hit assign and select one. I'm going to choose character 3. And now in our ready method, we simply go to our character to kill and call the die function. And if we run this, indeed, the die function is called on our character 3, which is our knight. So it says knight died. And if we choose another character, say the first one, we are instead killing the potion seller. Really cool. Inner classes. These are classes that exist inside of another class. We mostly use these for bundling together variables and maybe add a function or two. They can be a good alternative to dictionaries because they are sometimes a bit more safe to use. Say we have this character class here and we would like to add some equipment. We could create an inner class called equipment. So I'll write class equipment, and then we can give it a couple of variables. I'll create an armor variable, set it to 10 by default, and a weight of 5. Now we can use this class around our script. So we could 5. Now we can use this class around our script. So we could create some variables using it. I'll create a chest that is equal to equipment.new. Calling .new will create an instance of the equipment class. So now we have one piece of equipment, one instance, which is a chest. We'll also create legs, and again we'll call equipment.new. Then in the ready function, we can access these classes. So we can go into our chest and change the armor and set it equal to 20. We can then print chest.armor, or maybe print legs.weight. And this is also where you can see that this is sometimes safer than using a dictionary, because GDScript will recognize that there is a weight variable inside of the equipment class. And if we try to access something that isn't there, we'll get an error before playing the game, not only when we reach this point in our code. This is called being type safe. And now if we run this, we can see that each of the instances of our character will print these two pieces of equipment. And the armor of the chest is 20, and the weight of the legs is 5. Inheritance. So we know that all nodes in Godot are classes, and we can effectively make our own using scripts. But there's one more important thing we need to know to understand how Godot is structured: inheritance. Inheritance refers to the ability to derive one class from another. We've actually already been doing this. Notice how our script says extends node, so our script derives from the node class. This means that all the functions and variables of the node class are also available in our script. Godot actually has a very nice way of visualizing this. When adding a new node, we can see all the nodes available to us, but some of these are organized under other nodes. That's because these nodes inherit from the top ones. For example, both animated sprite 2D and camera 2D inherit from node 2D. This is because node 2D is a base class for all things that exist in 2D space. So since both a camera and a sprite needs a position in our world, they both inherit from it. And even cooler, we can actually find our character class on this list as well. That's because when we create a
what was that
character,
called? Back buffer copy? What does that do? That was completely unrelated. I just kind of did that out of nowhere, but what the fuck does that do?
Character class on this list as well. That's because when we create a character class, we're essentially defining a new node type, and we can see that it inherits from node. Really cool. Now, all of this probably sounds
oh shit, I didn't even notice that.
Because essentially
they both
inherit from it. And even cooler, we can actually find our character class on this list as well.
That's fucking awesome.
Because when we
I didn't know you
create
could
a
do
character
that.
class, we're essentially defining a new node type, and we can see that it inherits from node. Really cool. Now, all of this probably sounds a bit abstract, because it is. But what it means in most cases is simply that we need to make sure we inherit from or extend the right class for what we're working with. If, for example, we are making a script that moves around our player, we would create a character body node and add a script to that node. We could name it, say, player. And as you can see, this script then automatically extends character body 2D. And we now have access to all the functionality in it, such as the velocity and the move and slide function, which moves the node around. Composition. Now, even though Godot uses inheritance for its nodes, there are often better ways to structure your code. Godot actually leans itself really well to another way called composition. I'm not going to explain that here since there's already a really good video on the subject by a channel called Bitlytic, but I definitely recommend you check that out. Call down, signal up. When writing GDScript, there are of course many best practices that we can choose to adhere to. Going over all of them is a video on its own, but one that is particularly important is call down, signal up, which we use as a rule of thumb when communicating between nodes. Every scene in Godot is a tree of nodes, and the beginning of the tree is called the root node, which is the highest in the hierarchy. When looking at two nodes where one is right above the other, we say that they have a parent-child relationship. The node that is above is the parent, and the node that is below is the child, and that child might also have a child, and so on. Call down, signal up means that nodes are fine to call functions on the nodes below them in the hierarchy, but not vice versa. Instead, nodes below should use signals to communicate that something has happened. The nodes above can then connect to these signals as they choose and act accordingly. Think of it like real life. Parents are allowed to tell their children what to do, but children shouldn't directly command their parents to do things. Instead, children signal their needs to the parents and the parents decide the next step. Now keep in mind that this is a way to remember a good coding practice. It is definitely not parenting advice. But what if we need to communicate between two nodes that are on the same level? You guessed it, these are called siblings. Well, here the common parent is in charge of connecting the signal from one sibling to the function on the other. This is most often done in the ready function right at the beginning. So that's the idea of the rule, but of course always implementing this concept correctly requires some practice. I'll have a link to a good article with some nice examples. Style. During this video, I've tried my best to adhere to the official GDScript style guide. These are the conventions we use for naming and order to keep our code elegant and readable for others. I won't go into further detail here, but I'll have a link to the official guide. That was a lot of code for one video.
It was.
Of course, I haven't covered everything you're ever going to need in GDScript, but I hope this served as a nice overview of the most important aspects. Also, don't forget to check out Code Crafters. Become a better software engineer today by using the link below and get a free week and 40% off on your Code Crafters membership. So, this is the last video we've prepared for now. If you liked our new videos on Godot and have a topic that you would like to see covered, please let us know. While we don't know what the future holds, we've had a blast making these videos, and I hope you've enjoyed watching them. So, until next time, stay awesome and funky.
This guy's looking great.
Hey, it's Lucky.
Hey, Lucky. Region. So, I'm gonna take a second. Give me 1 second. I'm gonna actually, I'm gonna drink something real quick, and we're gonna actually go back into the we're gonna go back into this video, and we're gonna actually practice some of these so that I can try and get it drilled into my head. Watching it alone isn't gonna like really do anything. I need to actively do something. So give me 1 quick second. Be right back. Okay, I'm back. Sorry about that. I have a fucking white monster on my desk, and it was just looking at me so tantalizingly. Oops, that was the wrong one. Hold on a second. There we go. Better. Much better. So, we're gonna go back into this.
GDScript, a high-level, object-oriented...
GDScript's amazing. Better. Sorry, I just had something in my way. I'm trying to move things around. Okay. Hold on 1 second. Let me do this real quick. Forgot to open that up. Oh, it's not. One second. Deliver load. There it is. Here. Library. You launch. Okay. That's not. Yes, that's Discord. Hold on. There we go. So we're gonna fiddle around with this a bit. Okay. You know what? Just fucking delete everything. None of it matters. Get out of here. Delete. Yep. Don't want it. Hopefully I didn't break anything with that, but. Great.
Imperative and gradually typed programming language with syntax.
I do want to state real quick though, I do really like what they did with the UI. That's a lot better now. I think so, at least. Let me go to my editor settings. I want to look at something. Did they revert my theme? I think they did. Oh my god. Holy shit, that blinded me. I didn't know what that was gonna do. Oops. Reset. Oh my gosh. Oh god. I I just clicked the button. I don't know what I was gonna do. Just classic. Is that brighter? Like a little brighter? Oh, that's not too bad. I like modern a bit more, honestly. Color preset. Breeze dark. Huh. That's kind of nice. Godot 2. Ah. I wasn't around for Godot 2, so I never saw that before. Godot 3. Seems about right. Gray. I'm not gonna do light. I know what light's gonna do. It's gonna do what just happened to us. So I'm not gonna do that. Solarize dark. Ooh. Not too in the light. Black OLED. It's too dark, I think. I like default. I think I'm about to stick with default. Maybe darken this up. Okay, let me do this custom. Now let's do this. Darker. Single type it. There we go. Nice, comforting color. Okay, so anyways, we were fiddling around with this, right? Yeah, let's check this out. Let's see. Let's do loops. Let's start with loops.
Loops, loops, loops. Loops allow us to repeat code a number of times with small variations.
Okay. Let's just do a node. Regular old node. Let me actually look around here. Windows sub viewport. Be careful it doesn't create a window or draw to the screen directly. A particular region of a screen can be displayed independently. We use, for example, display UI in a 3D space. That's interesting. Okay. HTTP request. Multiplayer spawner and synchronizer. What the fuck? I'm getting distracted, but this is resource preloader. Plugin. I need to stop looking at these. All of them pop up. Just do node. Good lord. Oh, I know. Where's the video? There it is.
They are perfect for iterating through all the elements in an array. If, for example, we wanted to print out all the items in our array here, we can do that easily by using a for loop. So we write for, then the name of the item that we're currently looking at.
Touch script. Empty. Excuse me. What was he saying about the underscore part? Yeah, well, I think that means that that's a built-in function. Anyways, we'll worry about that later. Oh my gosh. That's not it. So if I do peanuts, chocolate, here. Oh wait, hold on, I need to make these their own things. Shit. There you go. Or let's just say list in items. Print. Wait, that's not right. Alright, what does this do? Okay, that's not right.
We'll just name that.
So it printed 3 times, but it's not. That's just gonna ping this 3 times, right? Yeah. Okay, let's try this. Let's see what this
Item. In the array, so in items, we will print out the current item we're looking at. So print item. And as you can see, it prints potion.
What? What did I do wrong? Oh, I did. Wait, no, that's not. That's what I messed up earlier, right? Yeah. Okay. What the fuck?
Current item we're looking at. So print item.
Oh, I'm printing the entire. Okay. Let's say. Yeah, that should be better, I think. Yeah, that works. What happens if I just change the word to something else that's not like list or something? Let's see if I say it's gong. Ping gong. Yeah, it's not declare the current step. That's why. Yeah.
And as you can see, it prints potion, feather, and stolen harp. This is cool because we can have any number of items in our array. The code will work just fine. We can also add more functionality, say to only print items that are more than 6 letters long. If item.length, so the amount of characters in item is greater than, let's say 6, then we're going to print that item. And now it only prints feather and stolen harp because potion is exactly 6 letters. We can also create loops that run a certain amount of times. Potion is exactly.
Oh well. Do 7. It's only gonna print chocolate, right? Yeah. And then we do 6. It should do all of them. Yeah.
6 letters. We can also create loops that run a certain amount of times. If we write for n in 8, it creates a for loop where the variable n starts at 0, then goes all the way to 7. So if we print n, we can see that it runs 8 times and n starts at 0 and ends at 7. We say that n is the current iteration of the loop. Another type of loop is the while loop. This repeats as long as a certain condition is met. Now, I think most people who know me would say that I'm a glass half full kind of person. And to those who disagree,
made
let
up
me
a
go ahead
word
and
there.
prove
That
it
was
by
just...
using a while loop to fill up a glass halfway.
Yeah, I just
So
wanted
I'll
to see
create
how that
a
worked.
glass variable and default it to 0.0. The glass is currently empty, no arguing about that. Then we'll create a while loop that continues while glass is less than 0.5, so we haven't filled it up halfway yet, in which case we will add a certain amount to our glass. We could do a constant amount like this, or in real life when I try to pour something into a glass, I'm not that precise, so let's add a random number instead. So we'll add a random float between 0.01 and 0.2, and then we'll print out how much is in the glass at the current time. Then, when the loop is done, we get to continue down here in our code, and we'll print that the glass is now half full. And if we run this, we can see that the glass slowly becomes more full with a random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because, and then it's glass
plus equal to... Oh, hold on. This. Oh, this. 220. Okay.
Is now half full. And if we run this, we can see that the glass slowly becomes more full with a
That's... Oh. We're just making shit up. Huh. Perfect.
the random amount each time, and then it says that the glass is now half full. As you can also see, it overshoots a bit because we're adding a random amount each time and not clamping the value, just like when trying to hit exactly half a glass in real life. My wife says that I add too much milk when I make her coffee. I think I'll refer her to this going forward.
Yeah.
Now, we actually have to be really careful when using while loops, that we don't create an infinite loop. These can be tricky to avoid and can very easily crash our program. Say if I were to remove this line that adds a little bit to our glass every time, well then our glass would actually never become half full and we would be stuck in this loop forever. Now, I don't think this will actually crash Godot, indeed it didn't, but we get a lot of overflow errors, and as you can see, our game is definitely not responding. Not good. Finally, in both for and while loops, we can use the break and continue keywords. Break, as the name suggests, breaks out of the loop and moves on to the code after, while continue immediately skips to the next iteration of the loop.
Oh, I did it
so
the wrong
if
way.
we were to write if glass is greater than 0.2 and then break, we can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index.
Yeah, after it's near 10,000, it's like, nah, we're done.
Dictionaries hold what we call key value pairs. Let me explain. In real again 0.2 and then break, we can see that our while loop ends way early because we exit out of the loop before we even get to print that the glass reached 0.2. Dictionaries. They sound really boring, but they're really cool. While arrays are great for storing lists of elements, it's sometimes confusing to access each element with an index. Sometimes it makes more sense to use a dictionary. Dictionaries hold what we call key-value pairs. Let me explain. In real life, we use a dictionary to look up the definition of words in a language. The key in this instance is the word we're looking up, and the value is the definition. Dictionaries in GDScript work the exact same way. Creating an empty dictionary is really easy. We write var, I'll call this one my dict, and set it equal to some curly brackets. This is an empty dictionary. We can then add key value pairs inside the curly brackets. Say for example that we have multiple players in our game. We can use a dictionary to keep track of them. Each player has a username, this will be the key, and a level, this will be the value. So I'll create a player called Crook, and his level is going to be 1. I'll create another player, Villain, with a level of 35. And finally, a player with the username Boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a
Boss. King. Kingman. And then
player with the username Boss with a level of 100. If defining on one line becomes too much, you can split it up like this. And it's good practice to add a comma to the last entry so you're ready for a new one. And let's name this dictionary Players. Then, to get the level of a player, we simply type in the username. Let's print the level of our villain. So print, and we'll write players, type in villain, and this should print 35. And you can just as easily assign a new value or add another entry. So we can
those square brackets. Player. Hit this. Boss. Right. Okay, now print just this. Okay, let's do print this. And then player Huh? What happens if I do this? Okay, that's not right. Let's just do 0. What does this do? It's not. Okay. Uh, Get it.
Assign the villain here to say 50 and add a new entry called Dwayne with a whopping level of 999. And just like with
Uh, uh, here.
with erase, we can loop over a dictionary with a for loop. When we do this, we are actually looping over all the keys in our dictionary, so all the usernames. And for each username in players, we will go ahead and print out the username. I'll add a string to separate, and then the level. So here we access our player's dictionary and input the
Plus. Okay. Okay, so for if I change this to names, again. Okay. So print out the name. So yeah, I just use that. But then when I actually define it to actually give the in this, so I give them this as well. Yeah, okay. I get it now. Okay, so what happens if I have more than one thing in here?
The username we're currently looking on to get the value. And remember to convert this into a string, so str, to cast to a string. There you go, it prints our entire dictionary.
Oh, they're already string values.
Now, just like with arrays, you can have multiple data types of keys and values in the same dictionary. And even cooler, you can actually have arrays or dictionaries inside another dictionary. This might sound really abstract, but it's actually pretty cool and often comes in handy. Say for example, we don't just want to store the level of each player, but also other info like their health. Well, then we simply replace this value with another dictionary. So open and close some curly brackets. Here we'll add a key called level with a value of 1, and another key called health with a value of 80. And at this point, it's a good idea.
Huh. Nice. Equal to 50. And then let's do speed. Two. One. Health equal to 500. Speed. And yeah. Forty. Equal to. How does I play it now? Oof. Bit like that. Where is the error at? Oh, I see. I was trying to add these into the print thing, but I can't because they're not strings. Let's watch. Yay.
Here to use tabs to keep our code clean. Let's duplicate this. I'll assign some values. And now we can access the value by using two keys. Let's print the health of our boss, so print players.
Brother, why the fuck? There we go.
We go into our boss, and we access the health. And this prints 500, which is correct.
Prediction. And then players.
So this way we can start to think of ways we can structure data.
Why the hell is his not breaking?
We go into our boss, and we access the health. And this prints 500, which is correct. So this...
I mean, it's because I'm mixing stuff up. This is a string, and that's a, that one's an actual thing, so I run it like this. No? What the hell? Wow. Well, it's because I don't. It's not. It's just pointing to nothing. I get it now. I think. I think it's because I have no like resource it's pointing to. It's just looking for speed when it can't even get past the first layer, which is the actual name of the characters or what have you. So now why does this one break? Because it's like skipping a step, right? It's trying to find something in here when it doesn't even know which of these it's pointing towards.
This way we can start to think of ways we can structure data.
If it changes the name, it should give me the right output. No? He... What? Oh, no? No. I thought I was missing something there, but I clicked it and it's like, oh no, you're not. You're good. So what's the problem here? Oh, hold on. I think it's happening earlier in the script. That's what's happening. It wasn't showing me that, I think. There we go. Name. And then... yeah. There we go. Now it's fixing. That's what was happening. Since I added a new dictionary thing to it. It was just looking for... this part was looking for nothing. It just found, it looked for the thing, but it couldn't assign it anything. Because that was a dictionary, not a string that could assign these values to. Name? No. Let's do help. So I screwed myself over by doing that. Yep. Now, how do I print something else out?
Yeah, about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags, structured data.
This isn't gonna work, right? Yeah, it breaks immediately. What? Is this? Oh, that works. Oh, well, that's... Yeah, it's pretty the right thing, but it's not on different levels. Don't know how exactly I should fix this, but alrighty then. Let's just do boss. Let's see what all it prints out if I just do boss. Yeah, I was specific about the name, but not the first one. What is that? Where's that and symbol coming from? Weird. This feels like a bug. I don't know what that's about. Because there's nothing in here that's like that. Let me just do this. Why is it doing that? Do not know. That being said, though, kind of works. So if I do diction, boss, well, health equal to 35, and then health. Yeah, sick. Okay. I'm getting it. I'm getting it. I think this makes sense. Just printing these out, though, is like a bit weird.
Yeah, about what's going on in our game, such as player stats, inventory, buffs, and so on. Enums. Enums are a convenient way to define tags or states in our game. Say we're making a game with a bunch of units and we want a way to mark each one as either hostile, neutral, or ally. In this case,
Oh,
we
there
could
goes my
create
light
an
again.
enum that defines these tags. So at the top here, I'll write enum to create a new enum, and then in the curly brackets, I'll write ally, neutral, and enemy. And now we can use these states in our game. For example,
let me just do something like this. I'm curious if I can mix these together in some way. The neutral. Did that exact
we can
opposite
create
order.
a variable called unit alignment and set it equal to any one of these states. I'll just set it to ally. And this makes it really quick and easy to then check in our code if our unit has a certain alignment. Also, let's just give our enum a name here to stay organized. So I'm going to call this alignment. And now whenever we are accessing
What?
a state, we have to go inside of alignment dot, and here you can see our state. So I'll go alignment dot ally by default, and then inside of ready we can check if unit alignment is equal to alignment dot, let's check for enemy, and if it is, we will print you are not welcome here. And if it's not, so it's not an enemy, we'll just write welcome. And now if we run, we can see that our
But that's so wrong. There we go. I know. So if I do,
our console displays welcome because our unit alignment is currently ally. This is much safer than using, say, a string or an integer to represent states, because Godot will throw an error if we misspell a state. If, for example, I misspell enemy, we can see that Godot throws an error. But I think one of the real powers of enums is that we can use them for exported variables. To do this, we mark our variable here with export, and then set the type to alignment. And now we can actually set our unit alignment in the
let me do this. Let me do ally, enemy, neutral. Commit. We'll do see. Alignment equal to plus alignment. And finally, alignment equal to so if I do that would be 0. Okay, yeah.
Inspector. So I'm gonna set mine to enemy here, and now when we play, it prints you are not welcome here. Really cool. Now what is actually happening behind the scenes here is that Godot is creating a constant for each state in our enum. So this code here is actually completely identical to our first line. And as you can see, the value
Okay, let me we'll try and make something here. Function. If hold on. I'm trying to think about this. If can love it. There we go. Standalone lambdas cannot be accessed. Consider assigning it to a variable. What? Damn it, this fucking error is giving me so much issues in the past. I can never remember. Ugh, so fucking annoying. Indentation, that's right. Got it. That was the issue last time I did something like this. Let me just cut this out. You know what? That's not right. Not clear in current scope. It's up here. Oh wait, no, it's in the ready. Fuck. Shit, how do I get around this? Clear the current scope. Let's just do a pass on this. And let's say this right here. We're gonna do it up here. Okay, so that fixes it. Yes, it fixes everything. Awesome. LF. Where the fuck? Fiction. There, a car. Equal to fiction. Equal to 1. Okay. Turn. Yeah, okay. Uh, Wait, hold on a second. I have an idea. Let's do character. Okay. Let's make some more variables, right? Or thing. cut this. I need to put this below this. Two. Fiction. Player. Nice. Okay, so uh this. What the fuck is ready at? Oh. Can I do this from there? Hold on. I think I have to do it after, but I'm not sure. Let me double check. Announcer. See. The let's just do this for right now. Uh, plus ring. Oh. Holy shit. That actually worked. Oh my gosh. Hell yeah. So if I do this and run it. No! What? Oh wait, no, I need the exported. Yeah. Yeah, if I do this instead. Yeah, I don't know why I set those up earlier. Hell yeah. Seriously don't remember why I set these up. Okay, but yeah, I did that. Oh my gosh. Shit! Oh man. Access to property or key. Oh, that's why. Okay. So it's pulling alignment. Yeah. I need to rework this then. So this would have to be. So this, I have to take the diction and redo this. One. Here. Uh. Let's identify after dot. I did that. Oh wait, no. That's why. Cyclic reference? Resolve member. Okay, I get it now. I get it now. That's what the problem was. Alignment dots. Enemy. And then this one can be dot. Right, and then I go player. Hit the alignment thing. Save. Break. Oh, I knew it was gonna break. Fuck. Let's get rid of this. I don't like that just being there. That's okay. So, all right, that's what was breaking it. Let's work this from the top down. Print. Let's just do this. Right. Let's just do a test. Plus alignment. Okay, it's 0. Right. Um. Okay. Oh boy, I don't know what that's all about. Um, uh, have to be the matching names. Yeah. Okay, now I need to. I'm working this all out in my head. Uh,
Here increases from 0 to 1.
Okay, let's see. Sorry, I'm like locked in right now. I don't want to export anything else though. Hold on. Okay. Ooh. Alignment set as an ally, enemy, and neutral, right? Okay. So alignments have been exported here. Yeah. Hold on. Let's try out some music for you guys. So there's a 0, 1, or 2, right? So let's use the variable character identifier and the function character identifier. 0, 1, or 2 is so where are these null? Let's just real quick. Why is this null?
Kind of like an index. So an enum is essentially
can't understand what I'm trying to do, right? I'm trying to make it to where it'll tell me what's the alignment of which one I have selected in the export thing, but why is this null? If I were to take a guess, I'd say maybe it can't go back that far or detect that far back as to what this is. Or it can't export that info. I'm trying to figure out what I can do to fix this. Hit play on this. Why is this not updating? Are you even allowed to export dictions? Or the dictionaries? He's let me do this, but it won't. Well, let me actually grab the dictionary. So I think my idea was doing from the start, if this is the case. Right? I just looked up on here. And UX. Oh, I guess. Oh, that's a neat way of doing it. I don't know what this is. So, this is neat. But still kind of not exactly what I'm looking to do. But for the most part, it's cool that I got that as like a thing I can export. Let me ask it this. See if we can figure this out. Well, it's just the right hand side equal. Yeah, I feel like I couldn't understand that. I'm on trying to what this means. Oh, I did not anyway. I mean, I guess I just wanted to be able to pull it from the dictionary. I only see the dictionary to characters. Got alignment. Variable. Fun up red, no. Okay, let's yeah, I get it. Yeah, okay. I get it. I think I get it. Pretty sure I understand what's happening. It's just that this can't be found by this because it's export doesn't really work that way. I don't know how to put it into words really. It makes sense in my head, kind of. I mean, I don't know the exact reason. Like a lot of the wording of that, what the fucking AI threw at me, I don't get what those words mean off the top of my head. I'm sure I'll figure it eventually, but I kind of understand what's happening here. But anyways, you understand what I was trying to do. Damn, I'm over time. Oh man, I enjoyed myself nonetheless. I'm having fun with this. I had fun actually trying to get this to work. Thing, and I made it overcomplicated and fucked this part up. But other than that, I'd say that was a successful day. I'm looking forward to doing some more tomorrow. I'm getting like increasingly excited because I'm starting to actually understand stuff and learn them. But yeah, we're gonna continue on again with
TD script.
With this some more. And we'll try and actually do more than we did last time. Like I like to actually learn stuff like signals and getters and setters and classes. Those seem like really cool stuff to actually figure out. But I'm enjoying the dictionary thing. That's gonna be extremely useful down the line. But yeah. Anyways, other than that, that's it for me again tonight. Sorry the light went out. I know I'm very framey looking, but yeah. Other than that, that should be everything. I'll see you all again tomorrow, and yeah. Have a good night, everybody. Bye bye.